Hey everyone, welcome to another deep dive. Today we're going to be diving into algorithms to live by. And, you know, you might not think algorithms belong outside of like a computer science class, but this book is all about how they can help us make smarter choices, in our everyday lives.
Yeah, it's amazing how often we face these dilemmas that computer scientists have been working on like forever. Things like trying to find a good apartment or the best person for a job or even, who to date. And it turns out there's actually a lot we can learn from how they've approached these problems.
Yeah, totally. Like the book starts with this idea of optimal stopping,
Yeah.
which is basically like, how do you know when to stop looking and just, make a decision? Like imagine looking at apartments online. How do you know when you've seen enough to actually choose one?
Right. It's about finding that balance. You don't want to keep searching forever and miss out, but you also don't want to just settle for like the first decent thing you see. So, Algorithms to Live By talks about this strategy. It's called the 37% rule
Hmm.
for, exactly these kinds of situations.
Okay, the 37% rule. That sounds oddly specific. What's the thinking behind that?
Okay, so let's say you're hiring someone, right? And you've got all these applications. The book says you should spend 37% of your time, just looking through them. Then the very next person who's better than everything you've seen before, that's the one you pick.
So if I had, say, 100 applications, I'd really look at the first 37 and then just be ready to hire the next person who really stands out. I feel like
Mm.
I could miss out on some really great candidates in that second group.
It does seem counterintuitive, but mathematically, it actually gives you the best possible chance of finding the absolute best candidate in the entire pool. Of course, you might skip over some people who are, pretty good, but this strategy is all about maximizing your chances of finding that top person.
Wow, that's kind of a wild concept. Reminds me of another idea from the book, this explore-exploit trade-off. It's like when you're deciding whether to go to your favorite restaurant or try someplace new, do you stick with what you know is good or do you take a chance on something that could be amazing?
Exactly. And computer science actually gives us tools for this, believe it or not. Multi-armed bandit algorithms, they're called, which by the way get their name from those slot machines you see in casinos. They actually help us figure out this balance.
Wait, slot machines. How do those relate to, like, choosing where to eat dinner?
Okay, think about it. With a slot machine, you want to find the one that pays out the most, right? But you have no idea which one that is. You have to balance trying different machines, that's the exploring part, with playing the ones that seem to be doing well, that's exploiting. So algorithms like the Gittins Index and Upper Confidence Bound, they give us strategies for this, like encouraging us to explore new options early on, but then also being smart about using what we've learned along the way.
So instead of just randomly picking a new restaurant, these algorithms could, like, help me strategically explore my options.
Yeah. In a way, yeah. They can help you balance that desire to try new things with, sticking to what you already know and love. And this isn't just theoretical, by the way. The book talks about how the Obama campaign back in 2008, they used A/B testing, which is basically a multi-armed bandit approach, to design their website to get the most donations.
Wait, so even something like a presidential campaign website can be optimized with these algorithms. It's pretty amazing when you think about it.
Oh, absolutely. And it's not just politics either. Think about clinical trials for medicine, They use really similar strategies to figure out which treatment works the best. We're actually surrounded by these algorithms all the time, often without even realizing it.
It makes you realize there's this whole other layer to how decisions get made, even in areas we don't usually think about. It's like these algorithms just running in the background, whether we're aware of them or not.
Exactly. And knowing how they work, it can be really empowering. It's like having a secret decoder ring for, understanding the digital world around us.
And speaking of hidden structures, the book also goes into this surprisingly relevant world of sorting. Something we usually think of as like organizing our bookshelves.
Right. But it's so much more than that. Think about how Google sorts its search results. It has to sort through like an unimaginable amount of information and then show you the most relevant stuff in like a fraction of a second.
That's true. I mean, Google makes it look easy, but there's some seriously impressive computing power behind those search results.
Absolutely. And while we tend to think that a perfectly sorted world is, ideal, Google actually shows us that often prioritizing QSEK searching is way more valuable.
That reminds me of the story from the book about that book sorting competition between the King County Library System and the New York Public Library.
Mm.
Apparently, the New Yorkers were not happy about losing to King County.
Oh, yeah. Their deputy director's response was classic. King County Library beating us this year. Forget about. It just goes to show that even in the world of sorting, there can be like drama and competition.
Haha, yeah. It's a good reminder that even seemingly boring tasks can have these like hidden levels of complexity and even, rivalry. But on a more practical note, the book seems to suggest that maybe instead of always trying to be perfectly organized, we should focus on making it easy to find what we need when we need it.
Right. And that leads us to another fascinating concept, caching.
Okay, so tell me more about caching. What is it, and how does it apply to our, daily lives?
Yeah, so caching is basically about like keeping the stuff you use a lot within easy reach. We do this naturally all the time.
Like keeping your phone charger by your bed or your keys in the same spot every day.
Exactly. It's all about anticipating what you'll need based on what you've done before. But caching, it's more than just a good habit. It's happening all over the place, like in computer memory or even with Amazon, when they ship you stuff before you even order it.
Wait, so algorithms are like predicting what we'll want before we even know it ourselves. That sounds kind of creepy, but also kind of cool.
It's true. And the book gives this fascinating example of UC Berkeley's library system. They actually have this like hidden cache of books that were recently returned.
Hidden. Why not just put them back on the regular shelves?
Well, they realized that, students often check out the same book like several times in a row. So by keeping those recently returned books in a separate spot, they could actually kind of like bypass the whole reshelving process, make them available again much quicker.
Oh, that's pretty clever. So they're optimizing for like convenience and speed, just like a well-designed algorithm.
Precisely. And it really just highlights how like understanding these principles can actually lead to real world improvements.
Totally. So we've talked about organizing information and then finding it fast, but what about actually remembering it? Because algorithms to live by also gets into that whole, the dreaded forgetting curve.
Yes, the never-ending struggle to hold on to those memories. Herman Ebbinghaus, he was a memory researcher, and he actually like mapped this out way back in the late 1800s. His experiments showed that basically we forget things really quickly at first, but then it kind of slows down over time.
Right, that makes sense. It's always easier to remember something you just learned compared to something from like 5 years ago.
Exactly. But here's the interesting part. Ebbinghaus, he also found that if we space out our practice sessions, it actually helps us fight that forgetting curve way more effectively than, like cramming all at once.
So like instead of cramming for a test all night, I should be reviewing the material like bit by bit over a longer period of time.
Exactly. It's about working with how our memory naturally works, not against it. Things like flashcards or even those spaced repetition apps, they can be really helpful for this.
It seems like there's this theme here, of working smarter, not harder, by kind of aligning what we do with these like underlying principles.
Absolutely. And that brings us to another super important concept, overfitting.
Overfitting. That sounds intense.
It can be. It's basically when we get like too focused on past data and then we kind of miss the bigger picture. Like, if you study old exams like crazy, but then you bomb the real thing because the questions are different.
Yeah, ouch. I think we've all been there.
Yeah.
So how do we like avoid that overfitting trap?
It's about finding that sweet spot between, learning from the past, but then also being flexible, being able to adapt to new situations. The book gives this really interesting example about how, like, our preference for unhealthy food is actually a form of overfitting.
Wait, you're saying junk food cravings are like an algorithm malfunction?
Well, in a way, yeah. See, our brains are kind of wired to crave things like sugary and fatty foods because for our ancestors, way back when, calories were hard to come by and they were essential for survival. But now we live in a world where food is everywhere, right? So that old wiring, it can lead us down the wrong path. It's like our brains are, stuck in the Stone Age.
So our cravings are like stuck in the past, focused on a problem that like doesn't really exist anymore. That actually makes a lot of sense.
Yeah, and the book gives another powerful example. It talks about training scars in, say, the military or law enforcement. If the training scenarios are too specific, officers can sometimes overfit their responses. Like, they'll react perfectly in training, but then in a real situation, something's a little different, and they freeze up or do the wrong thing.
So even if the training is well-intentioned, it can actually backfire if it doesn't like take this principle into account. It's a good reminder to always stay adaptable and, think on our feet.
Exactly. And speaking of thinking differently, the book introduces this really intriguing idea of relaxation as a way of solving problems, believe it or not.
Relaxation, that sounds
Yeah.
nice. But how does that work? Like when you're trying to solve a complex math problem, for example.
It's not about taking a nap in the middle of your calculations or anything. It's more about like simplifying those complex problems so that you can find a good enough solution quickly. The book uses this example of the traveling salesman problem, which is notoriously hard to solve perfectly. But if you like relax some of the rules a little bit, say, let the salesman visit the same city twice, maybe you can often find a solution that's almost as good, but way faster.
So sometimes going for the good enough solution is actually the smarter approach. It's about choosing the right tool for the job, I guess.
Exactly. And it kind of ties back to the idea that like perfectionism can really hold us back sometimes.
And speaking of which, the book gives this surprisingly simple tip to avoid getting, like, too bogged down in the details.
Hmm.
Use a thicker pen when you're brainstorming.
I love that analogy because by, limiting how detailed you can get with your ideas early on, it prevents you from getting lost in the weeds. It's a way to like force yourself to think big picture.
It's like you're forcing yourself to see the forest for the trees.
Mm-hmm.
So we've talked about thinking strategically, but the book also argues for the power of randomness, which seems kind of counterintuitive.
It does, doesn't it? But randomness isn't just chaos. It can actually be a really useful tool. I mean, think about it. Sometimes when you're stuck, the best thing you can do is shake things up a bit, right?
So instead of just banging your head against the wall, trying the same thing over and over, you introduce a little bit of randomness just to see what happens.
Precisely. Algorithms to Live By talks about something called randomized algorithms, which are used in situations where the traditional approaches just don't work. They basically introduce this element of unpredictability that can sometimes help you break out of those ruts and find new solutions.
So like using a random number generator to make a decision.
It could be that simple, yeah. The book uses the example of the Bloom filter, which is something that search engines use to quickly check if they've already indexed a particular website. See, instead of trying to store every single web address, which would require like a ridiculous amount of data, the Bloom filter uses this really clever trick that involves randomness.
That sounds pretty technical. So how does the randomness actually help the search engine?
Well, without getting too deep in the weeds, it essentially lets the search engine make these super fast and efficient guesses about whether or not it's seen a website before with a very small chance of being wrong. It's a trade-off that ends up saving a massive amount of time and storage space. But then even beyond those like technical uses, the book actually advocates for embracing randomness in our own lives too.
Okay, now I'm really intrigued. How can randomness actually make our lives better?
Well, it's about breaking free from our routines and, being open to new experiences. One of the examples from the book is using that random article feature on Wikipedia.
So you mean like instead of me scrolling for ages trying to decide what to read, I should just hit that random article button and see where I land?
Yeah, exactly. You might discover something totally new and unexpected that you would never, come across otherwise. It's about embracing a little bit of chance and serendipity, especially in a world that can often feel like overly planned out.
I like that. Okay, so we've been talking about like individual decisions so far, but algorithms to live by also dives into those situations where our choices are like bumping up against other people's choices. Enter game theory.
Right. And one of the like most classic concepts in game theory is the prisoner's dilemma. Imagine like two people get arrested for some crime, right? And
Okay.
the police, they offer each of them a deal. They say, okay, betray your partner and you go free. They get stuck with a long sentence. But then if both of them stay silent, they both get like a short sentence. But if they both betray each other, they both end up serving, a medium sentence.
Okay, so what's the dilemma? It seems like obviously staying silent is the best way to go.
Well, here's the thing. Each prisoner, if they're just thinking about themselves, will rationally choose to betray the other person, even though that actually leads to a worse outcome for both of them if they had just cooperated.
Because if, say, one person stays silent, but the other one betrays them, then the silent one gets like the worst possible outcome.
Exactly. So the prisoner's dilemma, it basically shows how even when cooperating is clearly the best strategy for everyone involved, that self-interest can lead to a less ideal outcome for everybody.
Yeah, that is kind of depressing when you think about how often that probably plays out, in the real world.
It is, but don't worry. The book also introduces this more like optimistic idea called mechanism design.
Mechanism design. What is that?
Okay, so it's this idea that we can actually design systems in a way that encourages people to behave in ways that are better for everyone.
So instead of just accepting like the prisoner's dilemma as this like inevitable thing, we can like actually change the rules of the game.
Exactly. The book uses this great example, the Vickery auction. So in this type of auction, the highest bidder, they win, right? But they only end up paying the price that the second highest bidder offered.
Oh, that's interesting. So why would they do that?
Well, it actually encourages people to be more honest with their bids. See, they're more likely to bid what they actually think it's worth because they know they won't have to pay like some inflated price just because they won. So it ends up creating a more like efficient outcome for everyone.
Wow, that is clever. It's like they outsmarted the whole prisoner's dilemma thing by like using incentives to encourage honesty.
Exactly. It shows that by really understanding these principles, we can create systems that, kind of nudge people towards being more cooperative and fair.
It's been so fascinating to dig into algorithms to live by with you today. Who knew computer science could apply to so much of our everyday lives? I feel like I have all these new tools now for like making decisions, solving problems, just navigating the world.
I'm so glad to hear that. That's what I love about this book, too. It takes these ideas that seem really complex, like, from the world of computer science, and shows how we can actually use them to understand ourselves and the world around us a little better.
It's like the book says, the algorithms we use to make sense of the world around us, they can also be used to make sense of ourselves.
Exactly. And it's not about, turning into robots or trying to calculate every single decision perfectly. It's about using these principles to help us think more clearly, make more informed choices, and, hopefully live just a little bit better.
For everyone listening, if you're curious about like the intersection of computer science and everyday life, or you're just looking for a new way to think about like decisions and problem solving, definitely check out Algorithms to Live By. It's super interesting and honestly surprisingly easy to read.
Yeah, it might just change how you see the world.
This has been The Deep Dive. Thanks for joining us as we explored this fascinating world of algorithms. We'll see you next time.